Here we are back in Chapter 8 on problem 8.12. And here we're dealing with the number of customers who enter a supermarket each hour. It has a normal distribution with a mean of 600 and a standard deviation of 200. And we're told that the supermarket's open 16 hours a day. So what we want to know is, what's the probability that the total number of customers who enter the supermarket in one day is greater than 10,000? So what we need to do is calculate an average hourly number of customers that's necessary to exceed 10,000 in one 16-hour day. So again, we want to go to a z-score, but the first thing we need to do is calculate the probability of that sample being greater than 10,000 divided by the 16. So here, let's do that calculation. Equals 10,000 divided by 16 is equal to 625. So it's equal to the probability of x bar greater than 625, and again, right here I've got the numbers laid out. So the sample mean, the x bar is 625. The population mean of 600. The standard deviation of 200. And again, the 16 hours a day is the n. And we're going to take the square root of that. And we see that right here. The square root of 16 is 4, which you probably didn't need the function to do that. But again, just to be clear as to how we got that. So, as we continue on then, we also can see, if I scroll over here, I've got a copy of the formula here. So you see the probability of the x bar, which is the sample mean minus mu, the population mean, divided by the standard deviation divided by the square root of n. So I guess we could have finished this one off equal, and now I can actually do this calculation. So it's equal to, since I have all the numbers over here in column J and K, so 625 or K7 minus K8, the mu, and then we're dividing that by the standard deviation. Oops. I'm going to put the parenthesis in there. Divided by the square root of n. Close parentheses. And that is equal to 0.5. So, if we were going to look at the probability of z being greater than 0.5 is equal to, and now we can go figure that out. So I'm going to scroll back here again and put the 0.5 right up here. So again, when we look it up in the table, it's giving you the area here, and we want the area greater than that, so we'll have to do a little bit of work there. But again, this is going to be found first in the table on page 310 for 0.5 on the row and 0.00 in the column. So let's go look at page 310 again in your book. And we can see that 0.5 under the z-score, and for 0.00 is 0.6915. 0.6915. And again, we could calculate that if we use the normal distribution function norm for S distribution, and again with a z-score of 0.5, and we'll leave it at true for cumulative. And again, we've got, just to change the display, we're going to decrease the decimal here to 4 decimals to the right, and then we see that we get that match. And now we would go probably 1 minus P for Z less than 0.5 is equal to, again here we're going to go equal to 1 minus, and we can pick either one of those 695.3085. So the interpretation of this would be, what is the probability that the total number of customers who enter the supermarket in one day is greater than 10,000? And that probability would be 0.3085.